forward for the near future to have more capacities of renewable energy. Thank you very much, Professor.
Any question? Are you happy? I am happy too.
There is one. Okay, please. No, she hasn't.
He's encouraging me.
Okay,
Thank you.
so the next speaker is Mahaswaran
Arumugam. Can keep this one. This is
Is it from
my one.
Mrs. Amita and others? Is it Nagla called the building and brighter future together? So
Okay.
from the school.
Can I put it back on?
And sorry, that's from.
Thank you.
Sorry. Yeah, Marduk University, Australia. So we welcome our friend from the Marduk University. By the way, we have our conference, grand conference there next year. Is that right?
Yes. Yeah.
Yeah. And I think he has distributed some of the flyers of that conference, and there will be more on our calendar. So I leave the stage to you.
Thank you, Professor.
Sorry for pronouncing the name.
That's okay. Good evening, everyone. I'm Mahesh Arumugam from Western Australia, WREC University. I'm the. Oh, sorry. I'm the co-author for this paper as we are doing the geopolymer. And this is, I'm presenting for Amita Verghese. So any questions, surely I can answer it at my best. So first, yes, anyway, this is Mahesh. We call it in short form. Maheshwaran Arumugam is my full name. Okay, I acknowledge my country. We always respect our elders, the Aboriginals. So always this is our first respect to them. Okay, let me move to the topic. Yes, as we're talking about the low carbon emission and net zero carbon in 2050. So we are one of the part of the team in the world sailing towards that target. We're doing in different way. As we know well, the carbon emission from the cement, Portland cement. So currently we're constructing buildings using the Portland cement, using the bricks, bridges, everything. But here we try to make a bit difference. As you see, you can see the statistics here. It shows the carbon emission from, especially from the concrete, is 8%. That is the production of concrete throughout the world. So this is the key for us to work on this project. And what we're doing here, we're finding a sustainable solution that the world is looking for with the zero emission. That is our mission. And Amita Verghese is our biochemical engineer. She's handling the proportion of this chemical, geopolymer, and I'm doing the robotic on the most on the automation side. Basically, I'm from the mechanical engineering background for the last 20 years. So this is just an idea what we're doing here. So you can. I hope everyone know about the green cement we are talking about. That is the short form or the easy form to remember the geopolymer. So that is just replacing the Portland cement. That is, we call it callets, something we call it. That's what we are importing from the other countries, and we crushing that to make the Portland cement. But currently, we're trying to replace that raw material which really need to make the Portland cement, because the main purpose is not about the cost; it's all about the carbon emission. So, so that's a key for us now, and especially in Western Australia, we are dealing with a lot of improvement with the infrastructure currently. You can observe in last 10 years, the Perth city is developed a lot with the buildings and road structures. So it's very, very vital for us and for our team to work on this project for next 20 years. Yes, I just give the a bit more information about what is geopolymer cement. So as you can see, we can use the fly ash as the raw material. So where you get this fly ash? Basically, we get this fly ash from the coal, from the power plant. Currently in Western Australia, we're running around 5 power plants using coal to produce electricity. So as we're talking about the alternative way for the electricity to stop the carbon emission, but what is the leftover? What is the wastages? What we're going to do the wastages? And we have the answer for it. If I'm not wrong, I visited one of the power station in Cooley that having around 5 million tons of fly ash. You can see, I didn't bring the photos here because I'm having a presentation tomorrow about my manufacturing method. I can show it. That's my photo. I clicked it from my view. It's like a hill or mountain, you can say it. That much of abundant material available at this stage. So that is our key point to use it up. Even whatever the quantity we use it, I think we believe it can be exist for another 20 years. So we just work it out the 20 years first, then we find out the next. So basically, for the geopolymer, we use the fly ash, that is anyway like it's rich in silicon and the aluminum silicate, we call it. And the activator, it's a sodium hydroxide or potassium hydroxide. So that's the activator. So we are not doing the fuming action here. So there is no carbon emission. We're not using the fire in this production method. So addition of that, yes, there is some kind of slags and the aggregative materials to strengthen the end product. And yes, we can make a bricks, pillars, anything which we need it. We are just focusing on the raw material which really needed, but we can use it in product whatever you need in future. So currently in Western Australia, we're having a lithium slag, nickel slag, because Western Australia is full of mining. We have a lot of natural resources there. So it's very, very important for us to find a solution to reuse those materials. So this is some of the negative and positive and the advantage and disadvantages. I can go through a few things for you guys. Yes, geopolymer is eco-friendly, reduces the carbon dioxide, and no heat is required during manufacturing. Yes, that is the key. And is superior strength and low energy consumption, low carbon footprint, low shrinkage and heatage of hydrations. So that's the main thing. Yes, the mechanical point of view, it's a tensile strength, as you know well. Okay, it's not the ductility we're talking about the tensile strength here. So because when you're building a bridge, so surely you need to test that tensile strength or the brittleness. So those testing also it's already passed because we've done few testing so far. It's around 190 days of testing completed prototype. So so far it's very good result. We found it. Still we waiting for the end result. High compressive strength, flexible and strength, and highly resistance to chemical damage. That's the other thing, because like in Australia we don't use paints for the home much, so we just use the bricks and the cements to build it. So that's what we believe in. So there's no painting involved in it. So we have that still we're having the chemical damage, so it's exposed to the sun and atmosphere, so it's very important. And yes, this is a circular economy principles, and a lot to be done with this project, but this is the starting phase for us, and we are the team in the Western Australia, first dealing with this. And a little bit more about the product, how we're doing things. So main thing is procure, as I told, like fly ash, even red mud. Okay, red mud is also available in Australia, and even in India, some of the part is red mud is available. So you can use it whatever you want, but the focus is on reuse of waste material. So give you a go. And geopolymer concrete, yes, when you're mixing all these things, aggregating all that, that's our geopolymer concrete. So basically, this is a um, this one can be done like a portable type of production. So it's very easy to move the whole setup to one place to other place. So basic now there's like 16 coal power stations around Australia. That is all over. It's not about Western Australia. So total 16 coal station is available. So that is the scope of our project. So if I would say like one power station is we can use for like 20 years. So think about 20 power stations, and this is only I'm talking about fly ash. So we have a lot of lithium slags and nickel slags. So that's a lot to be done. So as a byproduct is a silicate, as I told here. So the fly ash, when you do the testing, that the chemical proportion is like rich in silicate and aluminum silicate. So that is the key. We started this project, keep running with that. So a little bit of overview of about the red mud currently available. Like this is interior Western Australia. It's Pinjarra, Kunana, Cooley, all those areas. You can see the who visited Australia can know that the land is almost red. So where you dig the sand, it won't change color from red. So this is one of the binding material as well. As you know well, in some of the Asian countries, they use this red mud to build the pot and all that. It's like a clay. So it's really very useful in our project. But we keep this as a secondary option, if I'm not wrong, because fly ash is my top priority to reuse the waste material first. This is still can be used any time. Okay, so now what we're going to do with this this geopolymer production? We are producing the cement. The green cement is there. So what is the end product we are targeting at this stage? So the main thing is like, for example, renewable energy is our new energy resources. So for doing the turbines, building the turbines to run the propellers over it, the pillars, all those, this is, we're going to use the geopolymer mixture. So this is the big scope at this stage, and Australia having a big investment, the Australian government having a big investment on this project. So this is what our first trialing project we're going to do. This is just overall view how it's going to work. It is like it's a construction project. So like in this infrastructure, we having the solution for the surplus energy produced in the renewable energy system. So in the renewable energy system, we need the surplus to be moved to somewhere. For example, in my home in Australia, it's all the rooftop we having. There is no buildings built over. So we're having a plenty of places. So what I done, all the roof is covered by the solar power. So what's really happening with this? When I use at least like 100%, put it in that way. So, but the energy production now is like 35 degree to 40 degree the temperature in October, November, December, and January. It's around 4-5 months. So I am producing more electrical energy which I'm not needed that much of energy in this 4 or 5 months because it's very hot. So we're having the solution that is a gravity system, solid gravity system for the surplus energy to reuse here. So this gravity system used the big cubes, I can show that photos. You can see that this is the best example. This kind of cubes, squares need to be, isn't any shapes based on the trialing, how they do. So this is another scope for us to do the geopolymer using this, because you can see that, I just bring it up for the example how the a gravity system works. So whenever you get the surplus energy flow in, sorry, you can see the surplus energy flow in, okay, the motors start running. So that pull the weight on the top, and whenever the energy you needed, it work like a generator. It produce the energy, electricity. So that's what the storage system works. This is just an example how the things works. But our scope is to manufacture this kind the square blocks like these blocks. So the example I can given here is 3.5 meters, 2 meters, and into 1.5 meters. So approximately like 30 metric ton. So it's very big project it is. Thank you. So this is the precast turbine tower footings. This is just a flow diagram how this works. So you can see that the green one is the fly ash nickel slag. So that is our precursors. So that's the raw material anyway. We're not using all the things in one time. This is our totally entire system, how that works. So actually my part, I'm going to explain more about this one tomorrow in my slide. So this one we make it fully robotics. There's no any manual method involved in it. And this is the flow chart of how the things works. Yeah, of course, yes, so this curing process is not there. We're going to remove that anyway, because when we designing the project, initially we thought like we can little bit of adding a curing process plus add the chimney to reduce the carbon. But during some testing, we not needed this process, so we're going to remove that one. Apart from that, we're going to keep, this is the actual formula, how the system going to work. This is an example of the water windmill in the future and the current one. So we just get some data, how many things are working on the project post as well in Australia. Yes, we're doing the tailing prototype method at this stage. We get more good results. Maybe like, I think in the world, too many teams working on this, but our results are very good because of the method we are using. We are proud to say that one. Yes, as a conclusion, yeah, as a green power corridor. Okay, so it involves like turbine, even renewable. It's the GPC is having both systems, renewable energies. One is the turbine, and another one is like uh, solar power. So we got two incorporated in this, but currently we are focusing on the windmill. But still we are working on that pillars for constructing the solar panel over it. Yes, that's from me.
Thank you
And
very much. Well done.
you get in. Any
I was happy
questions?
to see that the electric good comes into at least 6 gigawatt. Yes, Professor, you have a question.
Yes, could you please, thank you very much for the presentation.
Thank you.
And could you please explain where the fly ash comes from, the use of this?
Oh yes, very clear. Very clear. It's from the coal, because currently all the power stations use the coal to produce energy. So basically, that is from the coal, burning the coal.
Thank you very
Thank
much.
you.
Yes, Professor.
Very interesting work, actually.
Thank you.
Because you are already using cement altogether, right?
Yeah.
Replacing it with recycled material, fly ash, basically.
Yeah.
It's very interesting. Why do you have the fly ash? Good enough. So, yeah, if you're still using coal, that's a good news. But yeah, the business are very interesting. It's very strength, very high quality. It's very good. I wasn't sure about energy storage because if you have these blocks,
Yeah.
I guess when you have electricity, say during the daytime using solar power, you run the motors to pull the blocks up,
Yep.
and at night you can let them
It's
by
dropped. Yeah.
gravity go
Yep.
down.
So
That's a limited amount.
it's a great finding. It's a great point. I just clarify again. This is just using for the surplus energy, not for producing the electricity, but still we designed in such a way we can get back some electricity from that during the dropping time because it's connected to the dynamo. Yes, correct. But still we use the grid because we Australia planning to move to the atomic, that's a nuclear system. So that is one of the main cause we're not using coal anymore in Australia. But still the grid system in place until we sophisticated with the enough energy we are producing through renewable energy system. So until we still depends on the grid, but the gravity system why we are implemented here, we are producing lot of energy in the summertime. So we need to find a way to get the surplus energy to get rid of from the grid line.
I can give you an idea
Yeah.
that you might consider as well. In Morocco, for example, what they do is during the daytime, they pump water up their mountains near the Atlantic Ocean. I think perhaps 1,000 meters high. So
Yes.
these towers,
No, it's
so a lot of water,
yeah.
a big water tank on top of the mountain. So at night, when they let the water down by gravity, you got so much water, so it will continue and you get all the energy back.
Sure, like this is a little bit of demographic, but currently where we're trying to set up the plant, the first plant going to be in the Cooley area. There we don't have any mountains or the dams or anything. It's a very dry spot that is. So look like 100 or 200 kilometers, square kilometers. There's nothing there. So surely that's a good idea and a very useful way, another way of helping the peoples. We surely consider that if anything resources available.
Thank you so much. There is another last question.
Please.
Thank you very much for this presentation. And I must tell you that with our partners in London South Bank University, we're working on something similar. I'm not sure if you have heard about it or not. Have you heard about graphene?
Graphene?
Graphene, yes.
Sorry, no.
Yeah, graphene is a product made out of biomass waste or carbon, where you extract carbon from the atmosphere or you produce it from biomass waste, and it is used as an additive to replace cement or reduce cement by up to 70%.
Wow.
So that's I was asking if you know it, how you compare this to your results.
Sorry if I'm not wrong, it's not graphite, is it? It's not graphite.
Graphene.
Graphene, okay. No, we've not done any research on that area, but surely we'll check it up. It can be helpful. It's a great idea anyway. Thank you so much.
Thank you. We are now taking some online presentations. So we are starting with the first presentation for Dr. Muhammad Hassan and co-authors, other doctors. The topic is clean energy applications and their impact on the status of international policy. So, are you sharing? I share. Ashema Muhammad. So, uh, all these online are from King Faisal University, Saudi Arabia. Oh, okay. So this one is from King based on university in Saudi Arabia. And sorry, Shayma, Mohammed,
Yes, yeah.
Mahmoud, Hassan,
I think 12 o'clock, 12,
thank you.
12:15
You
tomorrow.
got 10 minutes, please. 10
Polymer,
to 15
geopolymer?
minutes.
Okay. 12:30, 12:40. Yeah, yeah.
You can start now. Is your, is it mute? Just check, please.
11 to 12:30.
Yeah, you are mute.
Where is that?
Unmute, please.
I can see here.
We cannot hear you. As Shayma, we cannot hear you.